Why doesn't a ladder slip when you climb it? Or a seesaw topple over? It's all because of a key physics concept called static equilibrium. By the end of this video, you'll understand what equilibrium really means, the three magic equations that control it, and how to look at a problem and know if you even have enough information to solve it. What is static equilibrium? Let's start with this book on a table. From your earlier classes, you know it's not moving. The word for not moving is static. The word for all forces are perfectly balanced is equilibrium. So static equilibrium just means the object isn't sliding away, the object isn't spinning or toppling over. So first let's talk about translational equilibrium. Think about a tug of war. If both teams pull with the exact same force, the rope doesn't move. The leftward force is perfectly canceled by the rightward force. This is translational equilibrium. In physics, we say the sum of all forces in the horizontal or x direction is zero. It's the same for the up and down y direction. The book's weight pulls it down due to gravity. The table pushes up with an equal opposite force, which you know as the normal force. They cancel out. So the sum of all forces in the vertical or y direction is also zero. If both of these rules are met, the object will never slide away. This is the first part of being in balance. Now, what is rotational equilibrium? Look at this seesaw. The forces are not equal. The heavier person should be pulled down by gravity more than the lighter person. So, why don't they move? Because they are balanced in rotational equilibrium. In physics, you've learned about a turning force, which we call torque. The heavy person creates a small clockwise torque, but the light child is far from the center, so they create an equal counterclockwise torque. Because the turning forces cancel out, the seesaw doesn't rotate. The sum of all torques is zero. The three magic equations of equilibrium. And that's it. For any 2D object to be perfectly stable and in static equilibrium, it must follow these three rules. These are your new best friends in physics. Summation of forces in x direction is zero. Summation of forces in x direction is zero. Summation of all torques is zero. Think of this as your physics toolkit. You have three tools to solve problems. Now, determinacy. Can we solve the problem? This is the final clever part. We can use our three-equation toolkit to see if we have enough information to find the unknown forces in a problem. In math class, if you have one unknown, you need one equation to solve it. If you have two unknowns, you need two equations. It's the same in physics. Our unknowns are the support forces, which we call reaction forces. Let's count our unknown forces. This hinge support can stop the beam from moving left, right, and up, down. That's two unknowns. This roller support can only stop it from moving up/down. It's free to move sideways. That's one unknown. So, total unknowns are 2 plus 1 is equal to 3 unknowns. And how many tools do we have in our toolkit? 3 equations. We have 3 unknowns and 3 equations. Because they match, we can solve this problem. We call this a statically determinate problem. It's solvable. But what if your teacher gives you this? Let's count. Hinge A gives us 2 unknown forces. Hinge B gives us another 2 unknown forces. Total is 4 unknowns. But we still only have 3 equations in our toolkit. We have more unknowns than equations. We can't solve it with our 3 basic rules. We call this statically indeterminate. So, to recap, equilibrium means no sliding and no spinning. And a problem is determinate or solvable if its unknown support forces are equal to those 3 equations. Otherwise, it is indeterminate.